Good evening, everybody. Welcome to Chem 170 with your host, Dr. White. And this is our last week together. And don't forget, I will be giving the final exam on Wednesday, tomorrow. And at 8 a.m. or earlier, I will send out a password for the final exam PDF file. Now, a couple students asked if they could take it early, which is why I'm starting on Wednesday, which is all right. But you will all have until Friday, 8 p.m., the 26th, to take the final exam and upload your answers. Now, most students, if we are doing this face-to-face, which I give similar finals every year, you usually need about 75 minutes to 90 minutes to finish it. The slowest I've ever seen a student is about an hour and 45 minutes, and that student kept on checking her answers until finally she said, I've done it enough times. But normally I give students 2 hours face to face. Now, you can take as much time as you need, but get it uploaded on time. The final exam, like all my exams, will not be open notes. The final exam has 32 problems, 18 pages. Relax, take a deep breath. Students do well on my final. Some of the problems are multiple part, but I've never given multiple choice in Chem 170, and I won't. All right, the point breakdown. 30 points general knowledge, 62 points nomenclature. Remember, nomenclature is give the IUPAC name or the common name or draw the structure. And then 118 points reactions. And most of those are give the product or products. There are a few synthesis problems. Now, for test breakdown, what I did for the final exam also is the number of points from each test. Test number one only has 35 points. Why is that? Because that's pretty small compared to the others. Because I'm not going to ask you how many carbons are in the longest chain and things like that, because you've already learned that for other chapters, other nomenclature. Now, test two will have 60 points from the material, test three, 58, test four, 53. There'll be 4 points on the new stuff, which is proteins and amino acids. And it adds up to 210. So there's 10, 10, yes, 10 bonus points. Now, if you have any questions, email me on Thursday or Friday. Part of Thursday morning, I'll be busy, but Wednesday, I'll be around all day. And I should have added Wednesday there too. And I'll be posting your scores hopefully by Saturday, 7 p.m. or Sunday, 7 p.m. or earlier. And at that time, I will also put your final grade in D2L. Now, I'll also put it in the college system, but sometimes that takes up to 22 to 48 hours before you see it officially. But what you see in D2L will be your grade, along with what points you got. And I'll be doing the review tonight, which I am. Now, one thing, I'm just going to do a quick review. I'm not going to spend the next 4 hours going through a review of each test. Now, here I have watched these where I did it at the end of a semester, a couple hours of review. Don't forget to turn in any ungraded labs by the end of this week, the 25th, Thursday. And hopefully by tomorrow afternoon, I'll have all the labs graded. And if you don't see a score for lab you handed in, send me an email and I'll check and see why didn't I grade it. But I'm almost caught up. Now, how do you study for the final exam? The first thing is, even if we were face-to-face, I give back tests, you have your 4 hourly exams. Use those as your practice problems. You have the answers. You can find it on the video if you didn't write them down. Use those as practice problems. Am I going to use the exact problem on the final? No. But am I going to use similar types? Of course. Look at my practice problems from the D2L, and you'll see those are the types of problems I put on the hourly exams. That's the first thing. Now, listen carefully. Your friend, when you take the final, when you write down an answer, make sure there's 4 bonds to carbon. I would say over the years, about half the questions that I grade that are marked wrong is someone had taken the time to look at over that change. I only got 3 bonds or I got 5 bonds. That's always going to be wrong. Remember, there are 4 bonds to carbon. When you're doing a problem, remember that you break carbon-carbon single bonds. No, so don't. And when you look at a molecule, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And that will help you. Hopefully you've been practicing learning the general reactions. Now, what I'd like to do real quickly is just go through a few things students have problems with, or just to remind you. Remember, when you have a double bond, you react with HX, you break the pi bond, one carbon goes to H, the other goes to X, and that follows Markovnikov's rule. The carbon with the most hydrogens gets the hydrogen, the other one gets the halogen. And the same thing happens if you do acid plus water, where water is HOH. And this also follows Markovnikov rule. I forgot to write up here, X can be chlorine, bromine, or iodine. And the question would be, give the organic product or products are the following. So what do we do? Well, we've got a double bond. HCl is HX. X can be chlorine, bromine, or iodine. And you break the pi bond, one carbon gets H, one carbon gets X. It follows Markovnikov's rule. Well, do you break carbon-carbon single bonds? No. So I have 3 carbons. I better end up with 3 carbons. Here are my 2 carbons that are double bond. Let me go Technicolor on you. This has 2 hydrogens. That has 1. Hasn't the math been really tough in my class this semester? And which carbon has the most hydrogens? The end one. This one. So the hydrogen will go here, and the halogen will go to the other side. In this case, chlorine. You know there are 4 bonds to carbon. Chlorine counts as 1, so I can put the hydrogen in, and this is one way of writing it. And that's how you do it. I'm not going to go over any nomenclature. You can looked at in the videos I listed, or you can go back and look at each of the reviews, which you have the URLs for each hourly exam. It's easy to find. Let me just show you that. You go to my YouTube channel, you'll see for this summer, here's my introductory. Week 3 was test 1. Week one of these was test 2, other 3, and I'm going to have to post test 4. And I also have the reviews here. All right, let me do it again. Here's week 1, test 1, test 2, test 3, test 4. So the reviews are right there, the top row, when you have it set to show the latest. And you should watch those. Now, what I wanted to show was this reaction, something important. This is Friedel-Crafts alkylation, benzene ring, plus an alkyl halide, aluminum trihalide catalyst. Here, X is usually chlorine, but it could be bromine. And you form that special thing, a carbon-carbon single bond. Now remember to put the bonds in the benzene ring. If you do this, that's alkyl cyclohexane. You want a benzene ring, so don't forget to put the bonds inside that ring. And if we look at this product, we have a benzene ring. Don't forget to put the lines or circle what's R, and the carbon with the halogen is the carbon bond to the benzene ring. Put in your hydrogens because you know there's 4 bonds to carbon. I'll wait until everybody's finished copying that. Give me a thumbs up when you're done. Thank you. All right, let's look at this one. This gives students trouble too. I have that alcohol and reacted with H2SO4. Let me rewrite it so you can read it. And who's ever behind students, say hello from Dr. White. And heat can be either spelled out or you see a little triangle. And the question is, what's the product or product? And this is dehydration of an alcohol. And you get a double bond, and it follows Zasev's rule. And Zaysev's rule is you get the double bond, the alkene, that has the most carbon atoms directly bonded to it. You get the double bond that has the most carbon atoms directly bonded to it. So if we look at the compound, I have this carbon has the hydroxyl group. Where are adjacent next two carbons with hydrogen? Well, there's A and B. And for A and B, if you lose the hydrogen here from A and the one on the carbon with the hydroxyl group, you break carbon-carbon single bonds? No, you pour across that methyl, and the double bond will be formed there. Now, if you lose a hydrogen from B in the hydroxyl group, you'll form this double bond. And Zaysev's rule is you count the number of carbon atoms directly bonded to both carbons of double bond. In A, there's only one. In B, there are three. And now you have to use your high-level math skill, and which is the larger number. And time's up. Hopefully you pick B. Therefore, this is the answer, B. And that's how you do Zaysev's rule. Now, everybody got this copy down? Give me a thumbs up if you do. Nope, not yet. Okay. Now, historically, a lot of students have trouble with this reaction. Even though Dr. White loves this reaction, I use this in my PhD thesis. And the Grignard attack stat opens it up. Keep your eye on the carbonyl because that's where the fun is. What's attached to it are our prime, our double prime is still there. Now we're going to make a new carbon-carbon single bond, and this becomes an alcohol. And for some reason, students have trouble with that. Remember here, X can be chlorine, bromine, or iodine. Anybody having nightmares hearing me say that? Hope not. And here, what do we have? A ketone. Could have been an aldehyde. I'll call this R prime and this R double prime. Over here, we have carbon, carbon, oh, magnesium chloride. This is a Grignard. And this is my R triple prime. And what's attached to that carbonyl is still attached to it, R prime, R double prime. And now my R triple prime, the carbon with the Grignard is the carbon attached to the carbon with the alcohol now. And that's the molecule you get. Now, another Grignard that students have trouble with is if I do an ester. And here the giveaway is, I'm being nice, I'm putting the 2R triple prime MgX. X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to it are, there's going to be an alcohol here. And then you get, because you have the 2, and this part right here becomes the second alcohol. And the question would be, what's the 2 products? And on my test, when there are 2 products, I'll put a plus there. That's my gift to you. When I took it, we didn't get that gift. All right, so what do we have here? An ester. This is R prime. This is R. What do we have here? 2 of this Grignard, where our triple prime is this ethyl. So keep your eye on the carbonyl carbon. What's attached to it are methyl. Then you'll have your 2R triple prime ethyl. And this will be an alcohol. And then this part becomes the second alcohol. R prime is methyl. And that's what you get. And all the stuff, other reactions, most students do good on. But these are the ones students have trouble with. Now, leaving my class, you should know the following things. Excuse me. You should know how to describe how soap works, give the structure of soap. Soap has a non-polar tail, polar head. Water is polar. Dirt and grease are non-polar. The most important piece of the puzzle, which is why I'm going to a real large font, is light dissolves light. Things that are polar are soluble in polar things. Things that are non-polar are soluble in non-polar things. And when you mix them together, they're insoluble. Well, dirt, when you use water with soap, the non-polar tail of the soap is attracted to the dirt and the polar head wants to stay as far away. And when this is formed, this is called a micelle, and you should know that. And now I'm not going to draw them all in, but the soap particles are enough to totally surround every dirt particle. And water looks at the outside, at the micelle, and says, only sees the polar heads of the soap, says, I'm polar, you're polar, let's go down the drain together. And they do. That's one thing you should know, how soap works. Next, you should be able to describe with words and a general reaction what happens when you eat a fat or oil. In your stomach, there's acid and water, so it's acid hydrolysis. What's the functional group in a fat or oil? An ester. And a general reaction you learned for test number 3, ester, acid and water. If you wanted to, you could also put HCl. And you get back the carboxylic acid plus the alcohol you would have used to make that ester. So you should know when you eat a fat or an oil, how to describe with words and a general reaction. That's acid hydrolysis of an ester. And there's a general reaction. Getting dark out there, isn't it, Sam? All right, next, you should know how to describe with words and a general reaction when you eat a carbohydrate. An example of that would be like if you had a piece of bread, some rice, or sugar even, such as table sugar. What's holding glucose together in starches or carbohydrates? That's the acetal linkage. Since it's in your stomach, it's acid hydrolysis of a or an acetal. And for test 2, you learn acetal or ketal acid, and you could also write HCl here if you wanted to. Water, you get back the ketone or the aldehyde you would have used to make that acetal plus the alcohol. Remember, keep your eye on the carbon with 2 oxygens, becomes this carbonyl. So when you eat a carbohydrate in your stomach, or I think it's your large or small intestine too, somebody taught me one year, one of my students, because I don't know, I'm a chemist. I don't know biochemistry. All right, it's acid hydrolysis of an acetal, and there's a general reaction, acetal, ketal, acid and water, you get back the aldehyde or ketone, plus the alcohol you would have used to make that acetal or ketal. And finally, at the very end, I talked about proteins. And you should know what happens, how you describe with words and a general reaction, what happens in your stomach when you eat a protein. And if you saw the videos, the last part, you'll know what functional group holds amino acids together, and that's an amide. So there's acid and water in your stomach. So it's acid hydrolysis of an amide. And you learn for test 3, take an amide. Remember R prime, and you don't have to put this down here, but I will. And acid, and I'm going to use HCl for a reason why, and you'll see. You get back the carboxylic acid you would have used to make that amide, but because you're in the presence of base, of acid, I mean, and the amine formed is a base, which will react with the HCl to form this amine salt. And that's why I just didn't use H plus, because you see the counter ion on the amine salt. So when you eat a protein, the functional group that holds amino acids together in a protein is an amide. Now, protein chemists call it a peptide linkage. I'm a synthetic organic chemist. I call it an amide, which it is. And you get acid hydrolysis of an acid. You get back the carboxylic acid and the amine salt of the amine you would have used to make that amide. Now, the other thing I taught you new about proteins and amino acids, amino acid is short for amino carboxylic acid, and they all have this structure. And the carbon bonded to the carbonyl carbon, the alpha carbon, is the nitrogen. Now, what's a chiral carbon? 4 different groups, or 4 different atoms, or a combination of it. When R is not hydrogen, and I forgot the name of that amino acid, then the amino acid is chiral. Because the alpha carbon is a chiral carbon. And you learn that in stereochemistry for sugars or carbohydrates. Other molecules besides that can be chiral. With that, I'm going to say the first video I said in this class, you're going to learn that my world of organic chemistry is your world of organic chemistry. And now you have learned that my world of organic chemistry is now your world. And you're one of the few people on this planet who know about organic chemistry now. You should all be very proud. Thank you for being in my class. This is our last week together. If you ever need any help or questions in organic, you can always reach out to me. You have my email address. And for that, time for me to say, Gang gesund. Goodbye now. Stole that from Granny the Beverly Hillbillies.